In the last video, we've talked about what is a mole. A mole is a unit representing a quantity of particles. And here I'll show you, it is this number here. So when I think of a mole, I have 6.022 times 10 to the power of 23 particles. Now the question we have now is, okay, I know what the mole is, I know what it represents, how many particles I have. And the question is, how can we figure out the mass of a mole of material? And that is what we're going to talk about today. Now, welcome to this channel. If looking at the question, what is the mole? What is the mass of a mole? It makes you think, well, I need to know so I can succeed better in my class. Don't hesitate to subscribe to this channel. I'm going to create a database of videos for you to get better in chemistry. And as we go along, we're here to get better so that we can go to the next level of achievement at school. In order to understand what is a mole and its mass, we have a new word today. The new word expression is molar mass. So what is a molar mass? Here you have here the beginning. That looks like what we had earlier. So the molar mass of a substance is the mass in grams of 1 mole of any pure substance. Now, if you remember in grade 9 and grade 10, all the different experiments you've done, all the work you did in class, you work with pure substances. So for example, if I look at, for example, our periodic table, so I have this one right here. So when you look at the periodic table, we have the periodic table of the elements. And what are elements? They are pure substances of a specific substance. Same thing applies to molecules. For example, if you have CO2, you have molecules, and if you have a lot of them, you have a pure substance. So here that is quite important in what we're going to do as we move along. So let's look at an analogy. If, for example, I have a bottle of Tums like this. If you remember, you've been using this in your previous year when you looked at acids and base, and then when you were trying to neutralize an acid, you were using Tums, which was a calcium carbonate that was a neutralizing agent. But if you look at this bottle, in one bottle, I have 150 units. And each of the units here in this bottle weigh about 1.3 grams per unit. So therefore, the whole bottle is weighing 195 grams. So these are all information about this bottle. I can quantify this bottle as 1 unit, as 150 of the counts here, or 195 grams for the bottle. They each have different units to represent the same thing. So that means we can also have ratios that could work the same. We could have that one bottle of Tums equals 195 grams of Tums. That's something that is fair. We could also say that, so here in the same way, 195 grams of Tums is one bottle, or one bottle is 195 grams. Or you could say that 150 units has a ratio of 195 grams. So these ratios could be used when we do calculations. So what we have, so my next example with moles, when I have a set quantities of atoms or I have a set quantity of molecules, then I can actually find the mass of the amount of matter I have. And that's beautiful because soon we'll be able to mix it with the chemical equations where we have our reactions, and then we'll be able to know what is the mass of each of the reactants to give me a mass of specific products. And that's why it's getting exciting. So let's see if we can apply the concept of mole here. So here we're going to transfer this concept of moles and we're going to merge it to what mass is. And you'll see the relationship is amazing. Because if I have the number of moles and I know the quantity, and I've seen that earlier, because here we know that 1 mole equals 6.022 times 10 to the 23 particles. So that means that if I have a specific number of moles, I know how many atoms I have, and I can multiply by what is the mass in gram of that 1 mole. That could actually give me the mass of that substance. And let's see if I can make a calculation to show you how it works with aluminum. So here is a specific example. What if in a given situation I have 2 moles of aluminum? So here this is the information I have for my reaction. But I know that 1 mole of aluminum is 26.982 grams for 1 mole. Here, what do I end up for a total? I know that I have 2 moles here, so I have a unit mole. We have here at the denominator. The only unit I have left is grams. Therefore, I have 53.964 grams of aluminum here. Let's see if we can do the same thing with copper. Now, aluminum is found in, for example, in pop cans that you may have when you drink pop. What happens if I have, for example, three moles of copper? Now, that's interesting. I want to know what is the mass of 3 moles of copper. Now, interestingly enough, there's a way to find or figure out what is the mass of 1 mole. And there's a surprise. I'm going to show that to you in a moment. And here for copper is 63.546 gram per mole here. If I am to do the calculations, I'm going to use my calculator. We're going to do this fairly quickly. So we have 63.546 times 3. So that gives me a total of 190.638 gram. Now that's interesting. So somehow I can take moles and I can figure out how many grams that is. So the big question that some of you will tell me at this time is, okay, we know how the mole is working. Now we need to figure out, where do we find this information? How many grams do we have per mole for either aluminum? How many grams per mole do we have for copper? And the big secret is the following. I'm going to show you in one moment. And it is, let's see, it is the periodic table. You're going to say, okay, where is that information? You'll see, you know where the information is. We just have to show you. So here, I'm going to put this one right here. Perfect. So if you go on the periodic table and you look at each of the elements. So here you have iron, for example. The iron has an atomic number of 26. We know that 26 as an atomic number is the number of protons in the nucleus. And this is something you've done in the last couple of years. Now, we also have this number here that is called the atomic mass. Now, the atomic mass is interesting because that's a number that can help us with what we're doing. So let's see. If I go for aluminum right here, I will notice that the atomic mass of aluminum is what? 26.92. What do we have here? 26, and I'll show you here. Let's see if we can go back. Oh, I need to show you the screen. What do we have here? 63. You see, we look at aluminum, 26.982 grams per mole. If you go for copper for 63.546, let's go and have a look on the periodic table. Copper is right here, and we have the atomic mass of 63.546. So far, when you've been working with chemistry, you knew that the atomic mass gave you the information to know how many neutrons there were in the nucleus. Because what happened is you have neutrons and protons, which was the most mass in the atom. But now you know something new. You know that the atomic mass is actually the molar mass. So let's go back to our vocabulary, because vocabulary is very important. So when we had earlier the vocabulary that was molar mass, The molar mass is the mass in grams of 1 mole of any pure substance. If you go to the periodic table, you have all the molar mass for all the elements given to us. So that's exciting. So now we know what to do for atoms and elements. Let's look at 2 more examples to make sure we understand well. So for example, I mentioned that I have 5 moles of gold. We have the gold here. So that means that I need to go and see what is the molar mass. So I'm going to go here on the periodic table. And here, where is it? Voila. So you have here the atomic mass of the gold, which is 196.97. So that means that if you go into your equation, the 196.97 grams, that is for 1 mole of this element. We know that these cancel out. So here I want to know how many grams of gold do I have if I have 5 moles. So I have 5, let's use the calculator. 5 times 196.97, we end up with 984.85 gram. So interestingly enough, 5 moles of gold, it's very close to 1 kilogram of gold. So this is interesting. So this is a math we can use, and that's beautiful because in a lab setting, then we can start measuring what we need to know what we get as products at the end. So here's another example. Here I'm using oxygen as another element, and I have 196 grams of oxygen. What I want to know is how many moles do I have here? So I go on the periodic table, because our periodic table here is very important. We have oxygen right here, and the atomic mass is 15.999. Perfect. So let's go back here. We have 196 grams of oxygen times 1, and we know that 1 mole of oxygen, we just checked on the periodic table, equals 15.999 grams. Oh, I need to put the units here. Now here what is interesting is we can simplify units. So we have grams here and grams there. And if we use the calculator, let's see what kind of information I get. So I have 196 divided by 15.999. I end up with 12.25 moles of oxygen. So the whole idea here is that it is, so if you look at this, these are ratios and fractions. It's that easy, and when we understand that one is related to the others, then we can do all the calculations we can do. Looking at the calculations, I thought I would give you an extra one. So we had earlier that 5 moles of gold here times 196.97 grams per 1 mole of gold. That gave us earlier 984.85 grams of gold. Like this. For the same way, if it happens that I have that number, I have 984.85 grams of gold, and I know that for 1 mole, the mass is 96.85 grams, I can do the calculations by canceling the grams here, and when I do 984.85 divided by 196.85, it's 97, it happens, we end up with 5 moles. So this is actually the same information, but we look at it differently, because in some problems, they'll give you the number of moles and you need to figure out what is the mass. And sometimes they give you the mass and you need to figure out how many moles are involved. Now there's one more thing, and that's the next calculation I'm going to have, is how do we transfer the mass into the number of atoms. And that you already have all the information to answer that question. So let's see. If I have 5 moles, I know that I can multiply it by the Avogadro number, and that will give me how many particles I have. So let's see. If I have, for example, 5 moles of gold, and I multiply by, there's a 6.22 like this, times this 10 to the 23 over 1 mole. This is a particle. By doing the calculation, I can actually figure out how many particles I have already. And this is something we had earlier in the previous video, and I'm going to put a card here if I remember, so you can look at it if you have a question. Now, if it happens that I have the number of grams, then we can do a similar calculation. So let's see. So I'm not sure how the editing will go, but let's see if we can look at the previous example. If I have here a set amount of grams of gold, and I multiply by the fact that 1 mole of gold is 196.97 grams of gold, I end up with 5 moles. We know that already. Perfect. Now, we can also have the mass of gold at the beginning, but we also know from the Avogadro's number that 6.022 times 10 to the power of 23 particles is the same thing as 1 mole of gold, but we know that 1 mole of gold is 196.97 grams. So here we end up with 3 numbers, and let's see if we can simplify them. We have here number of gram, and we have number of gram here. The only unit we have are particles. We have particles of gold here. So what we have, we take our calculator, and we have this number times this one divided by 196.97. Now, some of you may not have a scientific calculator. So is it possible to do this calculation without the scientific calculator? Let me show you. If I know that this one here is times 10 to the power of 93, I put this information right here, and I put it right there in the answer. But what I have to do is I need to look at all the other numbers in the calculation. So I take 984.85 times 6.022 divided by 196.97. When I have all these numbers, I end up here with a number that is not between 0 and 10. So I end up with 30.11 times 10 to the 23 particles of gold. But now, knowing how the scientific notation works, I can take this decimal point and move it this way. By moving it towards the left here, I end up with 3.011 times 10 to the power of 24. And that is our example here. How do I know this works? Because when I was in high school, I did not have access to a scientific calculator. Everything had to be done either with a pencil or in our mind, and therefore that's my trick for you. Now, if you have clarification questions or you want to know something else, put the questions in the comments below. I always look at those, and I'm going to use your comments, your questions, to create more videos just for you. And the purpose for this is I want you to get better, and together we can certainly do so. On this, I'm going to put here a link to another video you can go and watch. On this, be great, and I'm sure we'll succeed together in chemistry this year.